Let's continue with example 3. Here we're given a function and we are asked to integrate over region R. Okay, let's proceed with example 3, item 1. Okay, so here we are asked to integrate function fx, which is x squared y, and we are asked to integrate over region R, and our region R is set of points x, y, where x is between 1 and 2. So here you can see that x is from a constant 1 to a constant 2, and y is from a function of x to another function of x. So this is very similar to region R1 here, where x is from a constant to a constant. So the order of integration for dA would be dy and then dx. So we need to integrate with respect to y first and then with respect to x. Okay, so here our integration would be dy and then dx. So this is equal to x squared y. So dA would be dy dx. Okay, the limits for x would be from 1 to 2. And the limits for y would be from 1 minus x to square root of x. 1 minus x would be the lower limit and square root of x would be the upper limit. Okay, so here to evaluate the double integral, we need to integrate the inner integral first. So the inner integral would be integration with respect to y. So here we consider x as a constant. So x squared there considered as constant. So integrate y with respect to y, we get y squared over 2. And then replace y with upper limit square of x and lower limit 1 minus x. Okay, replacing y with upper limit, we have square root of x. Square that, then you get x, okay, over 2, and minus, replacing y with lower limit 1 minus x. We have that. Okay, and then simplify this. Right, I'm going to put a half here. It's a constant, so I'm going to write that before the integration. Okay, so now we simplify this as x. Well, expand 1 minus x squared will give you 1 minus 2x plus x squared. Okay, so simplify that. We get x cubed, and here we have minus x, so minus x squared, and here we have plus 2x, so that would be plus 2x cubed, and here we have minus x squared, so that would be minus x to the power of 4. Okay, all right, now integrate this with respect to x. So here we have a similar term, x cubed, and here we have another x cubed, so that would be 3x cubed. So integrate that, we get 3x to the power of 4 over 4. And here we have minus x squared, so that would be x cubed over 3. And here we have x to the power of 5 over 5. And then replace x with upper and lower limits. Upper limit is 2, lower limit is 1. Okay, replacing x with upper limit, we have 2 to the power of 4, which is 16, divided by 4 is 4. 4 times 3 is 12. And here we have 8 over 3 minus 32 over 5, so that is upper limit, minus the lower limit, 3 over 4 minus 1 over 3 minus 1 over 5. Okay, and then we get, okay, hang on, let me get my calculator. 12 minus 8 over 3 minus 32 over 5 minus 3 over 4 plus 1 over 3 plus 1 over 5. Then multiply with a half. Then we get 163 over 120. Okay, so here dA here, the integration, the order of integration does matter. We have to integrate with respect to y first and then x, because in this case x is from a constant to a constant. So this is example 3, item 1. Okay, now let's look at the next example, which is example 3, item 2. Here the function is for x minus y, and our region R here, set of points x, y. But if you look at the region here, we can see that y is from a constant to a constant. So this is similar to region R2 here, where y is from a constant to a constant. X is from a function of y to another function of y. So order of integration does matter. So in this case, we have to integrate with respect to x first and then with respect to y. Okay, so here we have the function is 4x minus y. Okay, so this is example 3, item 2. We want to integrate our function is 4x minus y. We want to integrate our region R. Okay, so but our region R is given a set of points x, y, where y is from a constant to a constant. So the order should be dx first and then dy. Okay, now let's look at the limits for y. Y is from 0 to 2. Okay, so the outer integral, the limits would be from 0 to 2. And for x is from y squared to 2y. Is that right? Let me check again. Yeah, x is from y squared to 2y. Okay, so again, we're going to evaluate this by integrating the inner integral first. So the inner integral is integration with respect to x. So here you consider y as a constant. So 4x, integrate, we get 4x squared over 2. And here we have y considered as constant. Integrate with respect to x, we get yx. And then replace x with upper limit 2y, lower limit y squared. Okay, now replacing x with upper and lower limit. So here we have 4 over 2, which is 2. And then replace x with 2y. But here we have squared. Okay, and then we have y. And then replace x with 2y. So this is upper limit. Okay, now minus the lower limit. So here we have 2. And now the lower limit is y squared. So y squared, and then we square that again. So we have y to the power 4 minus, and then here we have y, and here we have y squared. And we have dy. Dy. Okay, so here we have x squared. Replace x with y squared. So y squared squared, you get y to the power 4. Okay, now simplifying this. Alright, that would give you 2 times 4y squared, which is 8y squared. And here we have 2y minus 2y squared, so that would be 6y squared. And here we have minus 2y to the power 4 plus y cubed. Okay, now we want to integrate this with respect to y. Okay, integrate 6y squared with respect to y. That will give us 6y cubed over 3. And here we have 2y to the power 5 over 5. And here we have plus y to the power 4 over 4. Right, and then replace y with upper and lower limits. So 6 over 3 is 2. And then times y cubed. 2 cubed, that would be 8. and here we have 2 2 to the power 5 is 32 over 5, and here we have minus 2 to the power 4 is 16, plus 16 over 4 is 4, and then lower limit, which is 0 minus 0 minus 0. Okay, so that will give us, hang on, we have 16, 2 times 8 is 16, and then minus 64 over 5. Right, so that will give us 36 over 5. Okay, so that is the answer for number 3, item 2. Okay, next example would be example 4. I'm gonna save that for the next video.